All right, polar bears and polar cubs, let's talk about Boyle's law. So there's a few things that we got to get to before we get to Boyle's law, and that is some general rules with gas laws. The biggest one is that temperature has to be in Kelvin. Now, Kelvin doesn't have a degree sign. It's just Kelvin. It has no negative number, which is why we need it in Kelvin. Because if you had a negative number for a temperature, you could end up with a negative pressure or a negative volume, and that wouldn't make sense. So you're going to take your degrees Celsius and add 273 in order to find Kelvin. This equation can be found on the back of your periodic table in the upper right-hand corner. Two things that might be a little bit in your guys' favor is the fact that pressure and volume, they don't have to have a specific unit. They just have to make sure that the same unit is used for both pressures or for both volumes. So if you're going to use kilopascal, use kilopascal. If you're going to use liters, use liters. The four different types of variables, or the four different variables that we would be solving for, would be pressure, volume, temperature, and then N is the number of moles. We're not going to get into N until our ideal gas law, which is Pivnert, and that should happen, I think, a week from today. So then the final thing that we need to go over before we get to Boyle's law is the fact that we have something called STP, that is standard temperature and pressure, in which it gives us two numerical values without even actually saying it to us or writing it out. So I know that when STP pops up into a question, sometimes students see it and they go, I don't have enough numbers to complete the problem, but it's there within STP. That tells us that pressure is 1 atmosphere and temperature is 0 degrees Celsius or 273 Kelvin. So let's go through a little bit on Boyle's law. Boyle's law states that pressure and volume are indirectly related, which means that as pressure goes up, volume decreases, and when pressure goes up, volume decreases, and if volume goes up, pressure decreases. So if we do a sample problem, guess is just kind of one of the methods for you guys to write out all of your work. G standing for given, U for your unknown, E for the equation, and then you have S for substitute, and then your final S for solve. The biggest part or most important part of these questions is making sure that you label the numbers to their correct variables. If you make a pair and you make it incorrectly, it can throw your answers off. So P1 is right here, V1 is right here, and then we have P2. We're solving for V2. So V2 would be our unknown, and it's going to be in milliliters. Same unit that I had on V1. So we're going to use P1 V1 equals P2 V2, and we're going to solve for V2. So we're going to divide by P2. And now we're going to substitute in. So we have 0.947 over 0.987. And then also up top, we have to have our volume of 150. Now, there's a little bit of a double check here. You can ask yourself, what happened to the variable that I have two of? So I have two pressures. What happened to my pressure? Did it increase or did it decrease? If it increased, you should then realize if pressure increases, volume decreased. So your final answer should be something smaller than your original volume. When we plug this into our calculator, we're going to get 144, and then that's going to be milliliters. The reason for 3 sig figs here are both of my pressures have 3 sig figs. All right, I'm going to count down, and then you guys can work or check the answer to your second problem on your own. 3, 2, and 1. Here we have a V1, a P1, and our V2 has told us that it's just doubled, so that's 450. We're going to solve for P2. This is going to be in atmospheres. So we still are using P1 V1 equals P2 V2. This time we're going to divide by V2s to find P2. Plug it in. You get 225 times 0.75 all over 450. Now on this one, since they told us that the volume was doubled, you should kind of have an idea that your pressure should be half of what it initially was, giving us a final answer of 0.38 atmospheres. Finally, just to kind of show you that graph with volume and then pressure, if you put volume on the Y and pressure on the X, it is as pressure increases, volume decreases, or as volume decreases, pressure increases. You're going to get the same graph whether you put P or V, whether you swap it. All right. Best of luck on your worksheet, and let me know if you have